Hello. Today we'll be going over scalars, vectors, and displacement, as well as vector math and equations relating to vectors, which cover everything you'll need to help set yourself up for success in physics, because physics is very dependent on vectors. So without another word, let's get at it. So there's a difference between the quantity named scalar and the quantity named vector. Scalar is magnitude only, which means only size. I only want to know the size of it, or only size, or only the value. But vector is both the magnitude, which is the size, as well as the direction of the object. So I can say size or north, south, west, east, right, left. Any quantity, but I just need to make sure I specify direction. I could even use angles. It doesn't need to be one of these. Now, magnitude plus direction. There's an easy way to remember that. Remember in Despicable Me, when the villain Vector was jumping and screaming up and trying to prove himself to Gru, he was saying, I have both magnitude as well as direction. Well, this is what he meant. He has both colossal size or impact, and he also has a direction, which means he's going upwards in life or something relevant. So examples of scalar quantities include distance, speed, time, and mass. Mass makes sense because mass doesn't have a direction, right? It only has a value. Time also doesn't have a direction. Speed, however, you might think, okay, I can be going 5 meters per second to the right. So why doesn't speed have a value? Or why doesn't speed have a direction? Because speed is only the magnitude. Velocity is the quantity that has both magnitude as well as direction. So speed is just how fast you're going. Your total distance over your total time. And distance, well, this just means the total amount of space you have covered. Space you covered. Okay, it doesn't really have a direction. It just, even if you go like different directions, it's just how much did you travel? How far did you travel? But for velocity and displacement, that's a bit different. Velocity, you have to have a direction as well as a magnitude. So I can say 5 meters per second, but then I need to say, what is the direction of that? Is it going upwards, downwards, rightwards, leftwards? You see? That's what velocity is. It's this plus a direction. It's the speed, which is the magnitude, plus a direction. Now, what is the difference between displacement as in speed? Displacement and distance. Distance, like I mentioned before, is total amount traveled. So if I travel around a track, right? Suppose I run around a track for a track meet, or I was just running. So it's a circular track and I run 400 meters. The distance I would have covered would be 400 meters because that's how much I ran. But my displacement would be 0 meters. Can you try and guess why that is? It's because displacement doesn't represent distance. It represents how far away are you from your initial position. That's why it's displacement. How far have you been displaced? Okay? So if I run around the track and I end up at the same spot, I haven't been displaced much, right? I've stayed the same spot. That's why it's the same. And it can also be a negative quantity, unlike distance. Distance can always be positive. I mean, it always has to be positive or 0. Displacement, however, can be negative. For example, suppose I define right as positive and left as negative. Let me just get this out of the way so we have more space. Okay. If I move to the right 2 meters, my distance is 2 meters and my displacement is 2 meters. But if I move to the left 2 meters, my displacement is negative 2 meters, and my total distance is 4 meters. Because that means I travel 2 meters here, and then I travel 2 meters back again. But my displacement is negative 2 meters. Now keep in mind 4 meters is only assuming you traveled here and then you went back, in which case the displacement would be 0. So kind of a bad example, I guess. And displacement can be negative, right? Because you could be a negative distance away. The convention is to define left as negative. So if you go left 2 meters, that means your displacement is negative 2 meters. But your distance is always absolute value of that, or the magnitude, which is just 2 meters. We'll be going over more of that, so don't worry if it doesn't make that much sense to you. Okay. Distance counts steps and displacement counts the gap. How many steps you have taken versus how far away are you? What's the gap between you and the place you started? If I start over here, let's just say typical XY axis 0, 0. If I move 8 meters east, which is to the right, so on an x-axis it would be positive 8, and then I come back 3 meters west, my displacement would be 8 meters minus 3 meters, because I went east, but then I ended up over here, right, 3 meters backward. So I would subtract 3 meters from my eastward direction, which leaves me with 5 meters. This is my displacement. Let's write it as disp. But what would my distance be? Do you have an idea? Well, my distance would be 8 meters plus 3 meters, because distance is always the total, right? Even if I traveled backward and I ended up at the point 5, how much did I travel in total? I traveled 11 meters, right? So my displacement would be 11 meters. It's the total amount you've traveled. Displacement is just how far you've ended up, if you count this position at the start. Okay, so let's move on and try solving these problems. Okay, obviously I'll have more comprehensive problems when I push out the PDF for this unit, and I'll go over those as well. But right now, just focus on these. Okay, I'm assuming you gave it a try. A runner jogs 400 meters around the track and returns to the exact start. State the distance and the displacement. Well, like I said, right, the displacement would be 0 because he returns to the place he started. If he doesn't move from his initial position, displacement is going to be 0. Disp equals 0, and always remember your meters, right? I mean your units. So 0 meters. Now, distance is how much you have traveled. How much did you walk or run or step, right? And in this case, that'd be 400 meters. You ran 400 meters. Even though you ended up at the same spot, your distance is 400 meters. And because you ended up at the same spot, your displacement is 0 meters. Now, a car drives 12 kilometers north. Okay. And then it drives 5 kilometers south. Let me do this in a different color. 5 kilometers south. The opposite direction, right? Find distance and displacement with direction. Now, distance is just the total. How far have you traveled, right? So that's just going to be 12 plus 5. My distance is going to be equals to 12 plus 5, and we know this is all going to be in meters because actually kilometers. Look, that's exactly why you want to keep those in mind. I almost tripped myself up over there. Remember, keeping track with your units. So 17 kilometers will be your distance. Now your displacement, however, is you moved 12 up and then you came back down 5. So your displacement is going to be around here, right? Which is 12 kilometers minus 5 kilometers, because you went up 12, but then you stayed down. You came back down. Let's assume we're saying north is positive. So then it would be 7 kilometers. And that would be in which direction? You see how they're saying is displacement with direction? 7 kilometers to the north, right? Because we had it started 12 kilometers to the north, then we came south. But how much we came south didn't overcome the north. We're still over here. 7 kilometers north. And then this is just a conceptual question. Can displacement ever exceed distance? Well, we know that distance can exceed displacement. So let me draw out the 3 cases that you can have. First is you come back, you go in one direction, and then you come back in another direction. In that case, displacement is, if I name this A and B, A minus B. But distance is A plus B, which means in this case, distance is larger than displacement. Now, scenario number 2 is I go in both the same direction. Okay? That means my distance, I'm going forward. And I don't change that direction. I keep staying forward. I keep going forward. So there's nothing that brings me back or anything. So in that case, my displacement would be equal to my distance. Why is that? Because there's nothing that brings me back, right? There's no change in position after I keep going forward. So in this case, my displacement is both A, if I label this A, and my distance is also A. So in this case, they're equal. And there's never going to be a case where they're not. Where they're not the same quantity, which means distance exceeds displacement. So there can be a case where they are the same, they're not the same quantity, but not a case in which distance is larger than displacement, because that means distance is the total amount you've traveled, right? Displacement is how far you've moved away. You can't move away farther than you've traveled. Makes sense? Yeah, like move away is directly related to travel, right? How far you've traveled. So this would be a no. All right, that's great. Now